All right, I apologize for not being there today. We're going to go to our note packet today. We're going to go to page 15. All right, we're talking about the volume and surface area of spheres and hemispheres. I'm not going to do all these problems. I'm just going to do the first four, and then we'll do number 5, A, B, and C together as a class on Monday. All right, so you should be on page 15 of your note packets. We're on day 5 here. Okay, we are going to skip this orange peel example. Instead, I'm going to show you something else for the surface area of a sphere. So when I think about a baseball, all right, baseball, if you look at it, baseball is a perfect or is a sphere. Okay, if I were to deconstruct a baseball, like unstitch it, like you see in these pictures here, all right, a baseball, like these four, if you look in the bottom half, if you unstitch it, it's kind of like 4 little circles put together. All right, 4 circles put together. Let's see if I can, well, I don't want to copy and paste it, but if I take a screenshot of this here, all right, if I look at this, okay, if I mark this up, if you look here, right here is 1 circle, all right, there's 1 circle there, so it's 4 circles together. Well, how do you find the area of a circle? It's pi r squared. To find the surface area of a sphere, it's 4 pi r squared. To find the volume of the sphere, it's less, since volume is cubic units, I cube the radius, but I multiply it by 4/3. So it's 4/3 pi r cubed. Volume of a hemisphere, so hemisphere is half of a sphere. If you think about a globe, you think about the Earth, there's the northern hemisphere and the southern hemisphere. There's a northern half of the globe and the southern half of the globe. So it's half of a sphere. When we're finding the surface area, though, if you look at this sample here, okay, not only do you need to account for the spherical part, the curved part, but you also need to account for the base that's facing out. So you would think that it's like 2 pi r squared, but in fact, it's actually 3 pi r squared, because you have to account for this base that you could wrap wrapping paper around. And then to find the volume of a hemisphere, it's just 4/3 pi r cubed, and then I'm just going to divide it by 2. So really it's 4/3 times pi r cubed times 1/2. Or I would just get the volume of a sphere and divide it by 2. Okay? Let's find the surface area here. The diameter is 16, so the radius is 8. So the surface area is going to be 4 pi 8 squared. So 8 squared is 64. 64 pi times 4, which gives me 256 pi. Now, to find the long pause there. Long pause. So to find the volume. To find the volume, what the heck? Okay, sorry. To find the volume is 4/3 pi 8 cubed. How would I plug this into my calculator? I would do this. That's not the calculator. Use parentheses. 4 divided by 3 times 8 to the 3rd. Enter. And you may get a lot of decimals, and that's totally okay. All right, decimals are fine. 682. What was it, 682? Yeah, 682.67. And put pi and then inches cubed, and this should have been inches squared. To find the surface area here, it's SA equals 3 pi 6 squared. So it's 36 times 3, which gives me 108 pi. For the volume, I'm going to go 4/3 pi 6 cubed, And I'm going to actually get that, and then whatever I get, I'm going to divide by 3. Excuse me. So I get 288 pi, not 3. And then I'll just divide that by 2 to get my hemisphere. Because this here is just the volume of a sphere, but I want the hemisphere, so I have to divide by 2 to get 144 centimeters cubed, and this should be centimeters squared. You could have also just done a half, so if I had done this, 6 to the third, times 1/2, I could also do that, and that would get 144. Both would work. Remember, just slap pi on your answer. All right, number 3 is a little bit different. Number 3 says find the radius given that the surface area is 64 pi. So I'm working backwards. 64 pi equals 4 pi r squared. It says the surface area is 64 pi, so I plug that in for the surface area and then solve for r. Divide the 4r, or divide the 4 pi, excuse me. I get 16 equals r squared, and then take the square root, r equals 4. And you could say r equals 4 units if you want. That's totally fine. Find the diameter given that the volume is 288 pi. So volume, this is just so fun, isn't it? Like that, 4 pi r cubed, 4/3 pi r cubed. So the volume is 288 pi, so that goes into my volume. Okay, so we know that the pi's are going to cancel each other out, right? To figure out how do I get rid of 4/3, I could divide both sides by 4/3, but really all I need to do is multiply by its reciprocal. So if I multiply by 3/4 and multiply by 3/4, okay, that's what I would do. I would do 288 times 3/4, or times 3 divided by 4. And I get 216. So I get 216 equals r cubed, and then I need to, since it's r cubed and not r squared, I need to take the cube root of both sides. Now how you do that in your calculator is like this. If I go to my calculator, I press the math button, all right, and I go and I can find that. For me, it's the fourth one down, cube root of 216. Look at that, it's a nice number. So r equals 6. All right, we're gonna pause there and then I'll pick up the rest and answer any questions that you have on Monday.